Alright, today we're talking about rectangles. A rectangle is a parallelogram with four right angles. So it's a type of parallelogram. Therefore, everything that we already know about a parallelogram applies to a rectangle, because a rectangle is a parallelogram. It's just a parallelogram with more specific things that are also always true. More requirements of a rectangle than a parallelogram. So, for every rectangle, all of the things we learned about a parallelogram are still going to be true. The opposite sides are going to be parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals are going to bisect each other. Those are the 5 things that we learned about parallelograms. Those will all still be true for every single rectangle. Now, in addition to that, the definition tells us that a rectangle is going to have 4 right angles. That's not always true with parallelograms, but that will always be true for a rectangle. It'll have 4 right angles. And there's one other thing we need to learn about rectangles, and it's about the diagonals of a rectangle. So, right here we have a quadrilateral, actually a rectangle, LMNO. The diagonals would be line segment OM and line segment LN. Those would be the diagonals of the figure. Those are the diagonals of rectangle LMNO. Alright, let's find the lengths of these two diagonals. Well, how do we find the length of a line segment when it's on a coordinate plane? Remember, we can use the distance formula. If you find the distance from one end of a segment to the other end of the segment, that will give you the length of that line segment. So we're going to use the distance formula. Now, we need to have the coordinates of the two endpoints to make that happen. So I need the coordinates of O and M. So for O, the coordinates are -6, -3. When we go to the left, that's a negative number, and we go down, that's a negative number. Okay, for M, 4, 4. M is at the coordinates 4, 4. We go to the right, that's positive, up is positive. Okay, so now we just take these numbers and plug them in. Remember, the first number is always X, second number is always Y. First number is always X, second number is always Y. The 1's come from the same point, and the 2's come from the same point. Now we're going to plug these numbers into the formula. So x2 is 4 minus x1. Now x1 is a negative number, and we are subtracting this negative number. Anytime you subtract a negative, you are adding. Instead of writing two signs right next to each other, if you're subtracting a negative, you can change that to addition. y2 is 4 minus y1, and again, we're subtracting a negative number, so we're going to change that to plus. So 4 plus 6, you can type all this in the calculator right here once you've substituted it in, if you have a good graphing calculator. But we can do it on paper doing order of operations. Parentheses first, 4 plus 6 is 10. 4 plus 3 is 7. After parentheses comes exponents. Just remember PEMDAS, order of operations. So 10 squared is 100. 7 squared is 49. And we can add those together. And the square root of 149 is not a whole number, so it's going to have to be rounded, and it comes out to approximately 12.2, depending on where you're rounding at. So that's the length of the diagonal line segment OM. Let's find the length of line segment LN. So first we got to get the coordinates. L is at the point -6, +4. N is at the coordinates 4, -3. So there's the coordinates for line segment LN, for the endpoints, L and M. We're going to take those numbers and plug them into the distance formula. Remember, this is x1, y1, x2, y2, just like we did on the other one. So x2 is 4 minus x1, which is a negative number, so we're adding. You're subtracting a negative, so we'll change that to addition. Y2 is a negative 3 minus Y1. This time it's a positive number, so we're just doing regular subtraction. Okay, again, if you like to type all this in the calculator, you can type it in the calculator right here and it'll give you the answer as long as you do it correctly. On paper, remember in PEMDAS, order of operations, we do what's in the parentheses first. So 4 plus 6 is 10. A negative 3 minus 4 is a negative 7. Okay, after parentheses is exponents. 10 squared is 100. Negative 7 squared is a positive 49. I get a lot of students say it's negative 49 because if you type negative 7 squared in the calculator, it's going to give you a negative 49 because it'll only square the 7. It's not squaring negative 7. You have to put parentheses around the negative 7 before you square it for it to do it correctly in the calculator. Remember what squaring is. It's taking something and multiplying it times itself. 10 squared means 10 times 10. Negative 7 squared means negative 7 times negative 7. And if you remember your multiplication and division rules, a negative times a negative is positive. So negative 7 times negative 7 is a positive 49. Okay, we add those together. And notice you get the exact same thing. It's again going to come out to approximately 12.2. So what do we notice about the diagonals? They're congruent. They have the same measure, equal measures. So we can say that if a parallelogram is a rectangle, then its diagonals are congruent. Now, remember that in a parallelogram, the diagonals also bisect each other. So if these diagonals are the exact same length and they're bisecting each other, what happens is this diagonal is bisected, and then this diagonal is the exact same length and it's bisected. You end up with 4 congruent segments where those diagonals are splitting each other up into 4 segments. All of those segments are congruent to each other. Alright, so let's look at example 1. And try to take this information that we've learned about rectangles, see if we can use that information to solve some of these problems. Alright, it tells us quadrilateral MNOP is a rectangle. So I know this is a rectangle. So as soon as they tell me that, they've told me opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, there's 4 right angles, and the diagonals are congruent. They've given me all of that information just by saying this is a rectangle. Alright, the distance from M to O is 2x minus 8. Now, M to O, that's a difficult thing to label because it's being split up into 2 parts. So I am going to put that on there to show it goes from here all the way over to here and label that. And then the distance from N to P is 23. Same situation. Alright. So I look at what they've given me. Well, they've given me either a number or an expression for the lengths of the diagonals. Those are the diagonals that we've had labeled here. And so I think about what we've learned about the diagonals. We just finished learning that in a rectangle, the diagonals are congruent. That means they have equal measures. So anytime we have things that are congruent to each other, we set them equal to each other. I know those diagonals have the same length. They're going to come out to the same number. Set them equal to each other. And then it's as simple as solving for x. We want x all by itself. Got to get rid of the constant. Anytime you want to get rid of something, you do the opposite operation. So because it was being subtracted, we add it. And then x is being multiplied by 2. We do the opposite, and we divide by 2. And there's x. Okay. Example number 2. Quadrilateral JKLM is a rectangle. So again, they've told me this is a rectangle. So everything we know about parallelograms and rectangles is true. The distance from L to P is 3x plus 7. And the distance from M to K is 26. Okay. Let's see how we can figure this out. Again, we've been labeling diagonals. The difference is This time, they did not give me an expression for this entire diagonal. They gave me an expression for only part of the diagonal. Now remember that in any parallelogram, the diagonals bisect each other. So this diagonal is being bisected, split into two congruent parts. That makes this distance from L to P exactly half of this diagonal. So I got a couple different ways we can go about doing this. One, I could say, well, this diagonal is also bisected, and since they're congruent, remember it's 4 congruent pieces, I could first think if this entire thing is 26, this is 13 and this is 13 because they're each half of that. And since these are all congruent, I know that 3x plus 7 equals 13. Now, I think that's the easier way to do it. But let's say that you didn't think about doing it that way. Another way you can do it, if I have a half and I have a whole, 2 halves make a whole. So I could take what's only half the size of the other and I can double it to make it equal to the whole. So I could take that 3x plus 7 and double it because it was only half. If I double it though, 2 halves are equal to a whole. And I could set it up that way. So there's 2 different ways we could set up the equation and get the same answer. If I'm solving this equation, I would distribute. 2 times 3x is 6x. 2 times 7 is 14. I want to get x by itself. I'm going to get rid of the 14. It was being added, so we do the opposite and we subtract it. And then x is being multiplied by 6, so we do the opposite and we divide by 6. If I solve the other equation, I should get the exact same thing. 7 was being added, so we do the opposite, subtract it to get rid of it. X is being multiplied by 3, so we divide by 3. And notice I get the same answer either way. So there's just 2 different ways to solve the same problem. Alright, let's try example 3. Quadrilateral ABCD is a rectangle. The distance from A to C is 4x minus 13. And the distance from D to P is x plus 7. Okay, this one is very similar to the previous problem. Again, they gave me something for an entire diagonal, and they gave me something for half of a diagonal. Now, one difference is, on the previous problem, we had 2 different possible ways of setting up the problem. Whereas here we really only have one way. Well, there is another way, but we can't set it up this way. Because what I did to make that happen was take this and split it into 2 congruent parts and then set this equal to that half. I don't have just a number here, so it's a little more tricky to split that up into 2 congruent parts and set it equal to the half. So we're going to do what was the longer way on the previous problem. I have a whole diagonal, I have a half a diagonal. I'm going to take that half and multiply it by 2 because 2 halves make a whole. So if I take that half and I double it, now I can set that equal to a whole. 2 times the half equals 1 whole. So here's our equation, and now we just solve. We've got to distribute 2 times x, 2 times 7. Then we don't want x on both sides, so I got to get rid of one of them. I always get rid of the smallest one, but you can get rid of whichever one you want. So subtracting 2x would make that 0. It's gone. Over here, 4x minus 2x is 2x. Okay, so we got x in one place, so now our goal is to get it all by itself. So anything on the same side of the equation as x has got to go. I want to get rid of the 13. It's being subtracted, so I do the opposite and add it. And then x is being multiplied by 2, so we do the opposite and we divide by 2. And we'll find out x is approximately, or excuse me, is equal to 13.5. Alright, let's deal with angles. So far we were just dealing with segments, diagonals. Let's deal with angles. Use the rectangle KLMN and the given information to find the following. So let's think, since we're doing angles, What have we learned about angles? Well, for a rectangle, we specifically learned that it had 4 right angles. Also, in a parallelogram, we learned that opposite angles are congruent and consecutive angles are supplementary. And then while this isn't directly a statement about angles, we also learned that opposite sides are parallel. And remember, that's helpful with angles because we learned a lot of angle pair relationships that are either congruent or supplementary based on 2 lines that are parallel being cut by a transversal. So we can look for corresponding alternate interior, alternate exterior, same side interior, same side exterior, all those angles that we learned about before. Okay, so let's start filling in the information we know. We know angle 1 is 70 degrees, and we know angle 7 is 20 degrees. All right, well, let's start with angle 2. Remember, for a rectangle, it has 4 right angles. Right angle, right angle, right angle, right angle. 4 right angles. Now, remember your angle addition postulate. If you take an angle and you split it into 2 parts, those 2 parts still have to add up to equal the whole. So if this is 90 degrees here, it's been split into 2 parts. These 2 parts have to add up to 90. So if this is 70, this one has to be 20. 70 plus 20 is 90 degrees. So I know angle 2 has to be 20 degrees. And over here, same thing. These angles have to add up to 90 degrees again. This is a 90 degree angle that's been split into 2 parts. So if that's 20, this one has to be 70. 70 plus 20 is 90 degrees. Okay? Well, also think about the fact that the opposite sides are parallel. So if we got parallel lines, here's a transversal, we get a pair of alternate interior angles. So those have to be congruent. So if angle 2 is 20 degrees, angle 6 has to be 20 degrees. And then once we get that, we're right back to what we were doing a moment ago. These 2 angles have to add up to 90, so if that's 20, angle 5 is 70. And you should start kind of seeing a pattern on how this works as well. Same concept over here, parallel lines, transversal, you get a pair of alternate interior angles. So if 7 is 20, angle 3 is 20. Hopefully you see that angle 4 is going to be 70 degrees. These 2 angles have to add up to 90, so if that's 20, this is 70. Alright. Now we need to find angle 9 and 10, and they're a little different because they're where the diagonals intersect. They're not at the normal vertices of the rectangle. Think about triangles. In a triangle, the 3 angles in a triangle always have to add up to 180 degrees. Well, here's a triangle, and those 3 angles have to add up to 180 degrees. Right now I see 20 degrees and 20 degrees. So I should be able to find out what angle 10 is. Well, 20 plus 20 is 40. So if the 3 angles are supposed to add up to 180, there is still 140 degrees left. So I know that angle 10 has to be 140 degrees. And angle 9 and angle 10 are vertical angles. And vertical angles are always congruent. So angle 9 is also 140 degrees. Alright, so let's recap or summarize the things that we learned. A rectangle has 5 properties of a parallelogram and 2 additional properties that are unique to the rectangle. So, the 5 things that we know about all parallelograms. The opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. All right, those were the 5 things we learned about all parallelograms. So they apply to rectangles because a rectangle is a type of parallelogram. And then there was 2 additional properties we learned that are specific to rectangles that most other parallelograms don't have. And that was, one was in the definition, that it has 4 right angles. And the other one we learned is that the diagonals are congruent. So those are the things that we learned about a rectangle.